Hello everyone. So in today's video, we are going to go over this paper from NACL 2022. So the paper is titled Features or Spurious Artifacts, Data-centric Baselines for Fair and Robust Hate Speech Detection by Alan Ramponi and Sara Tonelli from Fondazione Bruno Kessler, Trento, Italy. So this paper is pretty recent and I'm really sorry if I mispronounced any of those names. Alright. So the abstract, also a disclaimer, this paper contains content that might be offensive or upsetting. So if you don't want to read such stuff, then I'd recommend you stop watching the video right now. Alright, so avoiding to rely on dataset artifacts to predict hate speech is at the cornerstone of robust and fair hate speech detection. In this paper, we critically analyze lexical biases in hate speech detection via a cross-platform study entangling various types of spurious and authentic artifacts and analyzing their impact on out-of-distribution fairness and robustness. So what they're basically saying is if you rely on only things which you learn from datasets, then that is not ensuring fair and robust hate speech detection because your dataset might be biased in some aspects, your dataset might miss out on some classes. So such things do not ensure model robustness and fairness. Okay. We experiment with existing approaches and propose simple yet surprisingly effective data-centric baselines. Our results on English data across 4 platforms show that distinct spurious artifacts require different treatments to ultimately attain both robustness and fairness in hate speech detection. To encourage research in this direction, we release all baseline models and the code to compute artifacts, pointing out as a complementary and necessary addition to the data statements practice. So all of this stuff is available on this repository. Right. So introduction. Hate speech in online social communities is a serious and pervasive concern which requires fair and robust automated approaches to be tackled at scale. However, despite the great progress in natural language processing for detecting hate speech, current models have shown to be brittle when applied to real world data exhibiting limited out of domain robustness and perpetuating and amplifying harmful social biases. Noticeably, hate speech detection systems are typically trained on data from limited language varieties, such as individual platforms, which inevitably exhibits difference in writing norms, language use, and hate target hampering generalization. So basically, what they're saying is that if suppose you have a gab hate corpus, you have the gab hate corpus, then the data the models are trained on when they use the gab hate corpus is specific to how users use gab, right? So they might have certain lingo which they're using, they might have certain writing styles which that platform users use, etc., which might not be indicative of how people might be using, say, another social media platform such as Facebook. One of the main reasons for limited robustness and fairness of mainstream hate speech detection systems is largely ascribable to the spurious statistical correlation between the surface lexical items and the labels in training data, which models exploit to derive predictions. So, I guess what they're trying to refer to is some phrases or some ordering of words is what the models learn to be indicators of hate speech. These biases are commonly referred to as lexical dataset artifacts and have recently attracted NLP community's attention, particularly in NLI studies. Efforts to tackle this issue in hate speech detection are instead rather scattered and mainly focus on fairness using datasets from few platforms, leaving the study of OOD robustness largely unexplored. We instead argue that fairness and robustness are strongly intertwined aspects and thus should be studied jointly with the goal to understand to what extent these two dimensions are related. Right, so table 1. So post wrongly classified as hateful by fine-tuned board classified due to presence of spurious lexical artifacts, so an identity or a non-identity, and their negative impact on fairness and robustness. So what have Jews done to you? This by itself is not hateful, but Bird says this is hateful, fine-tuned Bird says this is hateful, and you can see this might be due to the identity present here. Similarly, non-identity related, uh, it seems that it's using retweet and user as uh, metrics or say sorry artifacts to say that this is so hateful, but this is not, so it is not robust as well. And in this example you can see it's using identity as well as some other artifacts, non-identity artifacts, to think that this is hate speech, which makes it neither fair nor robust. Previous work has shown that state-of-the-art models overly rely on identity words like Jews and gay to predict hateful content, further demoting voices of people from already marginalized groups. However, non-identity lexical terms such as sport, announcer, and football are also often spuriously associated with hate speech due to the biased data collection process, undermining out-of-domain robustness. Despite the recent trend in minimizing topic bias in data sampling, we show that spurious lexical artifacts still remain highly predictive on certain distribution even if data has been sampled in a more attentive fashion. So, for example, artifacts that are potentially data or platform specific. So figure 1 highlighted in gray. So we'll come to this figure once we read this stuff. We argue that disentangling artifacts into fine-grained categories by means of a cross-platform analysis may be beneficial to drive a broader debiasing of current hate speech models, ultimately improving both fairness and robustness to OOD data. To this purpose, we critically analyze artifacts in hate speech detection across multiple platforms and propose simple yet effective data-centric baselines exploiting spurious lexical items. Alright, we show that although we achieve substantial improvements in out-of-domain fairness by exploiting spurious identity-related artifacts, this comes at the cost of robustness. This confirms that fairness and robustness are strictly interrelated dimensions that should be studied together in future research. Alright, so what they've managed to realize is that if they focus on one, then the other falls. So, or both of them need to go hand in hand, both robustness and fairness. Alright. So contributions. To the best of our knowledge, we are the first to conduct a thorough investigation of lexical artifacts across online platforms, disentangle artifacts into fine-grained categories, propose a viable data-centric approach based on masking that consistently improves fairness over all baselines across all platforms to foster future research. They also release a code, a disaggregated lexical artifact annotation, suggesting the inclusion of dataset artifacts in dataset statements, which can be easily revealed using our code base. Alright. So let's have a look at the diagram now. So illustration of lexical artifacts. I is authentic artifacts, identity related. Alright. A not I is authentic artifacts, not identity related. Alright. SI is spurious artifacts, not identity related. And items highlighted in gray are platforms, potentially platform specific. So all of these are spurious artifacts. So just the word woman or the word Nigerian itself does not imply that it is hate speech, right? So I guess this is what this diagram is trying to show. There are these extremes, but I'm not going to read them. I guess you get what's happening. So lexical artifacts are not all the same. We conceptualize dataset artifacts at the lexical level as emergent correlation between token and label input data consistently to lexical annotation artifacts in NLI. As such, given a target class C, we formally define lexical artifacts LC as the set of highly discriminating tokens for C, which comprise authentic artifacts, AC items that potentially carry useful information for the class at hand, and spurious artifacts SC items that are spuriously or undesirably associated to the target class, such as LC. So the total number of lexical artifacts is the union of both the authentic and the spurious artifacts. In the context of hate speech detection, we consider the hate class as C unless otherwise specified and simplify the notation from dot street to dot. Alright. We build our definitions on top of the categories of lexical biases by Zhu et al., which originally identified three bias groups: minority identity mentions, which are not offensive, minority identity mentions that are potentially offensive, and non identity mentions, uh, which are possibly offensive. We enrich these categorization by introducing a high level separation into spurious and authentic artifacts and including an additional spurious non-identity related category. Indeed, given the broad nature of authentic and spurious artifacts, we further categorize them in section 2.1 and 2.2. So, authentic artifacts. We define authentic lexical artifacts A as a subset of highly discriminating tokens which potentially convey hatefulness, profanity, or otherwise frequently associated with hateful contents. Intuitively, A is the set of artifacts which is likely to be informative to detect hate speech across distribution. Authentic artifacts flows includes minority identity related artifacts and non-identity artifacts. Alright, so identity related are basically slurs, non-identity are swear words. So these are the two groups present here. And spurious artifacts. Spurious lexical artifact S broadly includes all tokens which we do not expect to be predictive for the target class at hand. As such, we postulate that these artifacts are a main reason for insufficient robustness and fairness of current hate speech detectors and thus may play a positive role in lexical debiasing. We specifically focus on these artifacts in our experiments. As for authentic artifacts, spurious items can be grouped into minority identity related artifacts and non identity artifacts, the latter being currently disregarded in research investigating fairness only. So these terms like the word Muslim, the word woman, the word Islam by itself do not uh, should not be used to just say that this sentence is hateful because it contains this word. So, but hate speech detectors have started to rely on such spurious correlations and non-identity ones. So these words, which are platform specific and specific to the time frame when these were data was collected, also are unexpectedly being associated with hate speech. So now the data section. In this work, we focus on hate speech, so messages whose content spreads hatred or incites violence or threatens people's freedom, dignity, and safety, and whose target is a protected group or an individual targeted for belonging to such a group and not his or her individual characteristics. Hate speech typically encompasses serious cases of offense with severe moral and legal implication. Those cases that of primary importance for content moderation. We collect hate speech corpora that meet the following criteria. They minimize topic and author biases in data collection using alternatives to keyword and user searches such as pure or boosted random sampling. They pertain to different social media platforms and they follow similar annotation guideline where hate speech is clearly defined and separated from other types of offensive language. For each corpus, we create hateful and non-hateful examples. All datasets follow consistent pre-processing, deduplication, and anonymization. Got it? So these are just how they chose the datasets. Now let's have a look at the datasets. For Reddit, we use the recently introduced Reddit dataset by Vision et al., which preserves a variety of grammar, topic, and style features due to community-based sampling approach. The corpus contains 27,494 entries annotated following a hate speech taxonomy comprising abusive, non-abusive, and non-abusive, so they are subcategories as well. We followed a widely accepted definition of hate speech as abuse targeting a protected group or its members for being part of that group. To create a hateful label from identity directed examples and non-hateful label from the remaining examples. So they use the pre-existing taxonomy of that dataset to create uh, labels which fit their need. For the purpose of this study, we discard instances marked as requiring previous content to be interpreted. The hate speech dataset after pre-processing consists of 1688 hateful and 19888 non-hateful. So for a total of 21576 unique instances. For Twitter, we select a widely used hate speech dataset, so Fonta. The dataset has 99,996 tweets, hateful, abusive, spam, and normal. So similar to previous work, we disregard the spam, forming the hateful class and the non-hateful class. So you can see it's in all the datasets the hateful is quite less. For GAP, they use a GAP corpus whose data has been sampled purely randomly due to frequency of hate speech of the free speech preserving GAP social network. The corpus consists of 27,546 annotated with assault on human dignity, call for violence, and vulgarity offensive label. Similar to previous work, we take the union of human dignity and call for violence for hateful, while for non-hateful, they take the remaining examples. We also leverage target annotation and consider messages towards ideology or political groups as non-hateful to ensure consistency among datasets. As a result, the final dataset is 27,014 messages, 1785 hateful and 24829 non-hateful. And finally, they have Stormfront. We use a dataset pertaining to a white supremacist web forum collected by De Gilbert et al. Following a random sampling procedure. It has 10,944 messages with hate, no hate, relation, and skip labels. We perform correlation and skip exam. We remove relation and skip examples. since they require previous context or they represent spam, and they use the hate example for hateful and no hate instances for non-hateful classes. Alright, so I'll just be right back. Right, sorry about that. So disentangling lexical artifacts. In order to disentangle lexical artifacts, we first compute a correlation between each token and the hateful class, then assessing the cross-distribution indicativeness of each token. For segmenting text into token, we rely on training portion of each dataset and employ the word piece subword tokenizer as used in BERT. Alright. Finally, we perform lexical artifact annotation. So they're using word piece to break it into tokens, then computing the correlation of each token with the class, which is it the sentence belongs to, and then looking at it across multiple data sets to see how indicative is it of the hateful category. So in distribution artifacts, we follow Guru Rangan et al. And employ point-wise mutual information to compute the discriminativeness of each token to the target class. Since lexical artifacts are meant to be used for downstream debiasing, we argue that tokens should be consistent with input to the end model. As a result, we use token as given by the word piece subword tokenizer, the same tokenizer used by models employed in our experiment. Formally given a token T and class C, this is the definition of the point-wise mutual information. We further apply reweighting to emphasize highly discriminative token class correlations and normalize less than equal to zero values, since negative PMI scores are known to be unreliable on relatively small corpora, which theirs is. In preliminary experiments, we found similar results when using the byte level BP tokenizer as used in Roberta. Alright, a comparative assessment of different metrics for computing token class correlation is out of scope in this study and will be investigated in the future work. So instead of using PMI, what the metric they could have used. Alright. So discussion: the top 10 tokens on each platform that are more associated with the hateful class are presented in table 2. So for Reddit, for Twitter, for I guess this is Gab, and this is Stormfront. All platforms exhibit a variety of lexical artifact types. However, we observe clear divergence across distribution. While artifacts in Stormfront data are mainly related to race, on Gab the focus is religion. Reddit and Twitter conversation are instead more varied, with high occurrence of spurious non-identity artifacts like RT and people. Alright. So you can see RT is present here. It words like idiot and people are also present here. So cross distribution artifacts. When dataset from multiple platforms are available, we hypothesize that leveraging individual scores makes possible to better identify artifacts. So given the pointwise mutual information, the score of a token T for the hateful class C on a distribution D, so on a given dataset, they normalize it in 0, 1 by applying a min-max normalization function to enable cross-platform score comparability. Obtaining this, they further apply a log transformation to mitigate the skewness of the original PMI distribution. As a result, the final distribution score for each token is basically they first taken the PMI, normalized it between 0 1, taken the logarithm and averaged it. We then sort tokens by descending score, highlighting lexical artifacts that are so they've averaged it across different datasets, highlighting lexical artifacts that are highly discriminating for the hateful class across distributions. So table 2 shows the top 10 tokens after the cross-platform computation is carried out. So this is after the cross-platform computation, these tokens are the top 10. Alright. So discussion. As shown in table 2, cross-platform importance of tokens for hateful class denotes scores and thus ranks of lexical artifacts, which are likely to be more indicative on some platforms only. So what it is essentially trying to say is, if an artifact is platform specific, then this method decreases its scores, while consolidating the informativeness of cross-platform items like words such as words which are indicative. This confirms our hypothesis that encompassing multiple platforms is beneficial for capturing lexical items that are likely to be predictive across distributions. So if you look at 7, they found these suffix tokens which typically correspond to out of vocabulary plural suffixes of out of vocabulary words. So a word might then is broken down into this and another word. So artifact annotation. In order to disentangle lexical artifact for further debiasing, we select the K most predictive tokens given by the cross distribution rank of discriminativeness to be manually annotated. In our experiment, we set k is 200 as it matches the subset of token which are highly informative, so more than 0.33. Uh, this is we leave the investigation of large threshold for future work due to space and annotation constraints. Alright, and the main advantage of token level annotation compared to word level annotation is that it allows to discern generic subwords from hateful or identity related words. So homophobia breaks down into homo and phobia, which loses without losing important information when doing removal or masking. Alright. So all key tokens have been labeled as potentially hateful and or related to minority identities by two annotators, male and female, fluent in English with background in linguistics and NLP and past experience in hate speech activities with NGOs. So the annotators are credible. Each annotator was provided with 5 examples of tokens in context for enabling more informed annotation decisions represented by randomly sampled posts from the 4 platforms included in this study. After annotation, the 2 annotators were involved in an adjudication session in order to discuss the case of disagreement, followed by correction wherever possible. Then they calculated the inter-annotator agreement, Cohen's kappa, which is 0.6887, and before and 0.8311 after the adjudication session, which is pretty high agreement. Alright, so discussion. Although some case of disagreements were easily resolvable, we found tokens which are difficult to discern due to ambiguity, mostly subwords, or due to real disagreement in the interpretation. This is in line with existing work showing that disagreement in toxicity annotation is inherent to the task and cannot always be solved through majority voting or adjudication, because something which might be offensive to me might not be offensive to you, and vice versa. Interestingly, this disagreement follows the trend of cross-distribution rank of artifacts. We decided to leave the analysis of annotators' disagreement for future work, and we release these cases as disaggregated labels. In Table 3, we show the most informative artifacts by type, whereas the full list of spurious artifacts is in Appendix B. Alright. So what does this figure show? So these are the top K tokens. So how many top K you're taking. This is the kappa score for the full annotation of lexical artifacts and for decisions on potentially hateful or identity related artifacts ordered by informativeness according to cross distribution score. So after adjudication, the scores are always higher, and for top 25, for top 50, for all the different cases, and as it increases, the size increases, it's even higher. For cases of hatefulness, the difference is quite more, because I guess presume after uh, discussion it's more resolved. So you can see that identity is somewhat compensating for the difference in hatefulness. So experiments to investigate the impact of spurious lexical artifacts on fairness and robustness in hate speech detection. Similar to previous studies, we cast hate speech detection as a binary classification problem. So two classes, hateful, non-hateful. They carry out in distribution and OOD experiments, namely training and testing all models on the same or different platform data. We evaluate performance of models using macro F1, whereas for fairness we use false positive rates on test instances containing the spurious artifact identity mentioned consistently to previous work. We outlined the experiment setup in 5.1, whereas data-centric baselines are presented in 5.2. Alright, so these are the top 10 tokens per artifact. So for identity, authentic non-identity, and so on. If a variety of them is available, we indicate it with underscore. Alright. So experimental setup. For all our experiments, we employ the uncased BERT model as implemented in the Machamp v.2 toolkit. Since it has been shown to achieve state-of-the-art performance in hate speech detection, we use default hyperparameters and perform a grid search to determine the number of epochs, the learning rate, and the patch size using the search space suggested by Delvin et al. We use stratified train test data and dev data, selecting the best model based on the average macro F1 score of the on the deployment test across all platforms during fine tuning. We emphasize the minority hate loss using a cross entropy loss with balanced class weights. The final hyperparameters are 4 for epoch, 2 to minus 5 for 2 into 10 to the negative 5 for learning rate, and 16 for batch size. The experiments have been done in Tesla V100 with a training time range from 10 to 40 minutes each, and approximately 110 million trainable parameters. Alright. Baseline, we investigate the impact of spurious identity related and non-identity related lexical artifacts on the robustness and fairness of hate speech detection by employing the following data-centric baselines. So vanilla, we fine-tune BERT model on each corpus. Filtering, so Swayam Dipta et al. Have shown that the most ambiguous training data instances promote OOD generalization while preserving in distribution performance. We thus leverage the vanilla model's training dynamics to filter training data to contain the 33% most ambiguous instances, which was a subset size taken in the work. Intuitively, those are instances whose class probabilities fluctuate frequently across training epochs. We then fine-tune the BERT-based model on the resulting subset. This setup is similar in the spirit to the one employed by Zhu et al. However, we assess it on data from multiple platforms, also remove duplicate instances, which may potentially confound the debiasing results. Alright. For removal, so prior to fine-tuning, we naively remove any occurrence of spurious lexical artifacts from training and development data. This matches previously employed baselines for assessing fairness in hate speech detection. However, since we are also interested in OOD robustness, we experiment with two removal variants, one only the spurious identity and one spurious non-identity. We hypothesize that removing spurious identity tokens potentially improves fairness, whereas removing spurious non-identity tokens mostly contributes to out-of-domain robustness. Masking. We propose a novel data-centric debiasing alternative based on token masking. Instead of removing spurious artifacts altogether, we reserve a special token in the vocabulary of the model that we use as replacement for the spurious artifacts. So they're essentially masking it. We then fine-tune the model in the mask data. Intuitively, this way we encourage the model to blend all artifacts to a single contextualized representation that will never appear during testing. Also avoiding to redistribute the informativeness of spurious lexical items to surrounding tokens. As for removal, we experiment with both uh, masking the spurious identity and non-identity masking variants. Alright, so results and discussion. In table 4, we report the result for all baseline along with the in-distribution and out-of-distribution dimensions for from the lens of fairness and robustness. Alright, so this is quite a hefty table, but let's have a look at it. So these are all the baselines only, I guess. Yeah, for all the baselines. So this is trained on Reddit. So you have the score with itself. Then you have the score against trained here, tested on Twitter, trained here, tested on Gap, trained here, tested on Stormfront, and so on. So you can see for Reddit against Reddit, masking is the best. For Reddit against Twitter, for F1, removal is of spurious non-identity is the best. So in this way, you can interpolate, you can understand this entire table. Since we argue that in-distribution performance is not a reliable measure for the performance of a hate speech detection system in the wild due to space constraints, we here focus on the more realistic yet more challenging out-of-distribution setup. So filtering is not a one-size-fits-all solution. Despite the improvement in OOD generalization and common sense reasoning, question answering and NLI task, training on ambiguous instances collected from training dynamics is not as effective in hate speech detection. Instead, our results show that filtering leads to mixed results for auto-domain fairness compared to vanilla baseline. This is consistent with results on Twitter data Zoo et al. And we further confirm it in the case across all platforms. Importantly, we also notice that filtering has a detrimental effect on out-of-domain robustness, except for two cases, Twitter to Reddit and Gab to Stormfront. This indicates that hate speech detection is a nuanced task requiring more target approaches than automated data filtering. We notice this holds true also when employing less or more aggressive filtering thresholds. So they've done some experiments which are present in the appendix. Removing SI is not as strong as it has been previously thought. So removing identity terms from data altogether is a commonly used baseline. Indeed, our results confirm that removing consistently reduces the FPR on test instances containing those mentions compared to the vanilla baselines, with the only exception being Stormfront to Gap. However, it only improves the out-of-domain robustness on Gap to Reddit and Stormfront to Twitter. Moreover, it consistently scores lower than masking on fairness as discussed below. This raises the question of whether removal should continue to be used as fairness baselines in future studies. So what they're saying is naively removing all spurious identity mentions does not help. Masking improves fairness. When masking, we notice a consistent improvement in fairness over all approaches, both in distribution and out of distribution on all platforms. Reduction in FPR over the vanilla baseline is as large as 3 times as for Reddit, Gap to Stormfront, and uh, gap to Twitter show. Most of the remaining train test pairs show a 2x improvement in FPR, also compared to the common removal baseline. We hypothesize that improved fairness performance with respect to removal is due to the way contextualized representations are formed during training, as discussed in section 5.2. Despite being surprisingly simple, we envision masking as a strong baseline for future work. So spurious non-identity artifacts are not as useful as spurious identity artifacts. We observe that method exploiting this lead to mixed results. This suggests that while a substantial FPR reduction can be achieved exploiting spurious identity artifacts, robustness calls for more complex debiasing strategies. So this is pretty naively uh, debiasing right now. So we are doing basic masking or removal. Fairness comes at the cost of robustness. Overall, we observe an important trade-off between fairness and robustness. Data-centric approaches that achieve a consistently high level of fairness, like masking and removal, typically show decrease in-domain, in-distribution and out-of-distribution performance, with the exception of Reddit to Reddit, Gap to Reddit for masking, and Gap to Reddit and Stormfront to Twitter for removal. On one hand, this suggests that spurious identity-related lexical artifacts do play an important role in performance across distributions. On the other hand, we believe this reflects the real performance of a prototypical model that is substantially faster. Alright. On one hand, this suggests that spurious identity related lexical artifacts do play an important role in performance across distribution, right? So they are giving some information, and like that might not be good information for the model to learn from, because it might then not be fair or robust, but this affects the real performance of the prototypical model that is substantially faster, and thus to which future work in hate speech detection should be compared to. We argue that masking represents a starting point to achieve both fairness and out-of-domain robustness. The latter requires more complex model-centric debiasing approaches. A summary of the results are presented in Appendix C2. And towards artifact documentation, the practice of data statement has been recently adopted in NLP community as a way to include relevant information about the creator methodology and possible biases. This should in turn have a positive impact on the system strain. We propose that an artifact statement should be added to this documentation as a way to contribute to diagnosis of pre-existing bias. It is one of the goals of data statement. In particular, we propose a template for lexical artifact documentation and publicly release code to ease compute ranked correlation between tokens and target classes of interest for a given annotated corpus to ensure the process of documenting lexical artifacts will be as smooth as possible, and thus allows widespread adoption of artifact statement in the future work. Our code automatically generates outputs in different formats from raw text to latex code for seamless inclusion in publications. We present the artifact statement template below and provide a full example in Appendix D. So the top lexical artifacts, which are the k most informative tokens in the corpus, which can be ranked list of k greater than equal to 10 tokens. If there are multiple classes of interest, top k lexical artifacts for each class should be included. Class definitions, so different definitions for the same class may exist across datasets. This impacts annotation, which has in turn an effect on the resulting lexical artifacts. An explicit definition of the target classes for which the top lexical artifacts are computed should be provided, alright. And method and resources. So the method used to compute the correlation between tokens, such as PMI or interpretability approaches, and the annotated corpus should be reported here. Uh, possibly Possibly with a link to code. If pre-processing and deduplication have been performed, they should be clearly reported. Resources such as full lists of lexical artifacts can be additionally included. Alright, so this looks pretty promising, because a lot of the times you look at the dataset which has been provided by some other research group, and you notice things so you might think, why is this a part of this class, and so on and so forth. So such in data cards and uh, model information, data artifact statements would really help. So related work, the problem of hate speech model generalization related to hate speech detection has been extensively discussed. Indeed, it has been shown that state-of-the-art performance overestimates the capability of models to yield the same results over time or across different domains. Possible mitigation strategies include domain adaptation, augmenting smaller datasets, the use of domain lexicon to transfer knowledge, and fine-tuning of hitboard on the target corpus. Concerning bias and fairness, several work have pointed out the presence of bias in hate speech and abusive language datasets. The issue has been addressed in different ways, including functional tests and post hoc explanations to measure model bias towards identity terms. As regards bias mitigation, the task has been addressed through a number of approaches via adversarial feature learning, by using debiased word embedding and gender swapped data augmentation, or by adding non toxic examples to better balance the data. The work probably most related to ours is Wu et al., which presents an analysis of lexical and dialectal biases in the dataset by Fonta et al. The authors propose lexical bias categories which we extend in this work. However, they focus only on one dataset and in domain bias reduction. Moreover, they start from a list of bad words, whereas we computed from data. To our knowledge, this is the first work advocating for a joint view of fairness and robustness, both identified as critical aspects related to classification of hate speech. So limitations our work is a step forward and towards better understanding bias. However, we are aware of limitation. So all findings are English related. Increasing availability of hate speech data in other languages than English should also be there. Annotated data from multiple platforms may not be available for some language, and then this limits cross distribution computation of artifacts. Lastly, we acknowledge spurious statistical correlation may go beyond the token level. We believe our studies are first step, and then they might look at maybe some n-gram level stuff as well. So the future direction is the conclusion is that this investigates the impact of lexical artifacts on OOD and fairness and robustness. It raises awareness on interplay between the two dimensions. They propose a fine-grained categorization of lexical artifacts and simple yet effective data-centric baselines, showing that while robustness calls for model-centric approaches, masking spurious identity artifacts is a viable approach that we argue should be used as strong baseline. In future work, we aim to investigate the role of dialectical biases and non-lexical artifacts, extending the study on language other than English. We release all baseline model resource and a code to compute lexical artifacts, broadly suggesting the inclusion of artifact statement as a way to document potential lexical biases when a dataset is released to provide a complementary view to the data statement. And then they have their ethical consideration. Uh, the annotation task was carried out by two researchers regularly employed by the institution. We do not foresee any specific ethical concern. Our goal is to propose artifact statement uh, to reduce bias. However, the identity-related and offensive tokens considered in this work are all in English and centered around Western cultural context. We leave the evaluation of a methodology to assess whether there are language or more broadly culture-dependent change for future work, following recent work on biases in geocultural context by Grove Shutter. And they've also thanked their funders. So I won't be covering the appendix right now. I'll read this myself over time. But thank you guys for joining in. If you have any suggestions, just let me know, and hope to see you again next time as well.